My name is Matthias. At my day job, I work at JetBrains in the night. If I'm not preparing slides, I'm creating an open source project, both of which you will probably see you will surely see during this presentation. So I'm talking about developing and deploying a static web app with Blazor and Azure Functions. And it was interesting because I actually saw there was already another talk, or maybe even two, talking about static web apps. And I can say the presentation is definitely, in terms of demos, more interesting. I hate to say it, but yes. But nevertheless, I think there are some bits here that I'm going to talk about, which are interesting as well. And well, you will see, I guess. So first of all, for those that are not yet aware what static web apps are, basically it's a new service, actually pretty new, where you can host your static content globally around the world with integrated API support, being Azure Functions in this case, globally distributed, I already mentioned. Also, this has a seamless security model between the two, between the front end and the back end, which is really cool, which we will see. It has integrated authentication providers, which, let me see, I always forget one of them, which are Google, GitHub, Azure Directory, and Azure Active Directory, Facebook, and Twitter. On top of that, we can freely customize our authorization, which is very, very easy to use, actually. It comes with custom domains, staging environments, free SSL certificates, and it also has integration with GitHub and Azure DevOps for deployment. Most of the right part things I won't talk about. Particularly, I'm not advocating, or at least in this part, I'm explicitly excluding the GitHub and Azure DevOps integration. I'm coming with a new approach. You can decide what's best for you. But yeah, other than that, for static web apps, we have a lot of choices for our front end. So we can use frameworks like Angular, Vue, Svelte, React, and Blazor. On top of that, you could also use static site generators like Hugo or Gatsby or Next.js. So there are a lot of choices, basically. But for this talk, I'm sticking with Blazor. Blazor, particularly Blazor WebAssembly, which allows us to use C#, .NET, which is great for me. I'm very difficult learning other things, I'll be honest. But this is generally a great approach. Just to mention, there's also the part of Blazor which runs on both client and server side, but Blazor WASM just runs on the client side. What is great about it is that it's based on an open web standard, which allows it to run in any modern browser, basically. It also comes with JavaScript interop, of course, and overall, it just has a great development experience. So that's what I meant when I said C#. You can debug. It just comes natural in many cases. And one of these examples I think is great for that is this little to-do list, which does nothing more than you have an input box and you can add items. Once you click them, they will be removed. And just for that, just a little bit of motivation or showcasing here where the power is. So this was, for quite some time, I was not a web development person, but I can really say that this, if we look at the implementation here, is really very, very straightforward. So we have an input text box, basically, which we then can bind to a backing field here, which we defined down here. Then we can also subscribe to the key events. In this case, we can check if at any point the user hits enter, just to take the item, actually add it to the list that we already have, set back the field that is bound to our input box. And then the real magic still for me, and I know at some point I should get over it, but the real magic here is that this part automatically gets rendered. So we will extend this unordered list to add the new items, which we added to that list. We can also, and this is so elegant, I'm lost for words almost, but we can subscribe to events also like on click, and then just have a delegate which then removes the current item from the list again. And this is just great. Speaking more about development here, debugging works with Blazor WebAssembly. So at any given time, we can add a breakpoint, we can inspect the variables or the results that we got returned, for instance, from this weather forecast endpoint. I mean, in this case, it's just a JSON file, but it works also with other endpoints if you happen to use HTTP client. And after that, of course, there's also the second part for static web apps, in this case, Azure Functions. And I'm sure many of you will know what Azure Functions is, but still, this whole thing works serverless. So we just put our code, which gets executed once there's a request, which provides very flexible scaling on that matter. And also comes with a just powerful programming model. So we use attributes to define when a certain function gets triggered, what input values we expect. We can actually also monitor the whole thing when they get executed and what they log, etc. And it also comes with a great development experience, being debugging and much of a like. So let's take a look at this function in particular, which is a function that gets a quote from another endpoint. So what I'm doing here is basically just defining an HTTP trigger. Then we have some logging going on here, then requesting the quote of the day from this particular endpoint. And this one actually returns a larger JSON response. But what we do in this case here is just grabbing the actual quote and then returning it with an OK option result. So very straightforward. We just put the string in here and that's it. One little reminder for those folks that don't know, do make sure that you're using HTTP client factory for that and get it injected. So, but what we also can do from here, from right inside the IDE, is to say, okay, I want to debug my function. Like here in the gutter mark, we can click that and either run or debug. Once I executed debugging here, then you will see that the function is available under this localhost endpoint. And then we can also go ahead and choose to trigger this particular function. And this will open in Writer, it will open a new document, which can be used to write HTTP requests. And besides, I mean, this is a very simple one. We can write get and then the endpoint that we're trying to access. But you can also do post requests, of course, and then add additional headers, like in this case here, the content type. By the way, this is pretty handy here because this how it's structured, it allows you also to trigger manually timer triggers. But let's go back to our usual quote. So what we can do from here is just run this particular request. Once we do this, and we're currently debugging the application, then we will also actually hit or break with the debugger. We can fully inspect what's going on, both in this case the request and the response that we're receiving from this other endpoint. And I would say this is just a great experience. Back to our HTTP request where we wrote that, you can actually also see the result that our function was actually returning. So here, this will be our quote, some other headers for the response that we got. And also this is tiny, neat little thing for different requests that you received. You can actually also from here compare different responses from a function if you happen to need that. But now we discussed the Blazor and the Azure Function side. Now we want to put that together into a static web app. And for that, the coolest part about this, besides being a unit, is that with this service we can actually make use of the integrated authorization providers, and in case where it's appropriate, we can tell the user that they're unauthorized, or if they're authorized but don't have access, we can return 4 or 3 for forbidden. So just to be a bit inclusive here, I also have the same response codes for docs. If you happen to be a doc person, I actually like both. But other than that, yeah, let's discuss what changes are needed on both sides. And we will start with the Blazor side. So for that, in Blazor, the first thing that we have to do is to provide links for the auth endpoints. Those will be available automatically. You don't have to do anything for that. So for your website, you will have an auth/login/provider endpoint for the different ones. Again, Google, GitHub, Azure Active Directory, Facebook, and Twitter. You will need to add the package, Microsoft Azure Functions Authentication WebAssembly. Very, very long name, almost gets an award for that. And in your program.cs, you will have to add the Add Static Web Apps Authentication call to the builder. And also one let's say, boilerplate thing is you have to use the cascading authentication state and authorized route view in the app. And once this is done, we can choose two different approaches. The first is if we have individual blocks in one single page that we want to treat differently for authorized and not authorized users, we can use this authorized view. And otherwise, if the full page should be checking for roles of the user, then we can just add an attribute. And so just to show this quickly in code, this is probably the most straightforward example for the component way. So on a page, if we check or for an authorized user, of course, we want to say hello to the user, versus when the user is not authorized, then we probably want to provide a link to the login providers. The second example is about our quote Razor page or web page that will be available then. So for that, all that I did was adding this attribute here. And yeah, admins you need to be an admin to receive the quote of the day. But this will actually then guard the web page from being accessed. Now, this is one part of the equation, the front-end part. But actually, we also need to guard our backend service with the appropriate authorization checks. And for that, we can just parse the JSON web token from the XMS client principal request header. From that, we can create a claims principal instance. And with that, we can actually check if the user is authenticated and is in a particular role. In code, it looks roughly like this. Again, on the left-hand side, you will see what I've changed here. The first part is we need to add a claims principal parameter to this. And just to bear in mind, this attribute here is something that I wrote. So currently, if you browse the docs for static web apps, there will be an approach where you just call a static class. I just found it interesting also to actually write an Azure function binding here in this case. You will have access. I will also provide the link to the repository. You can actually check that out. And otherwise, I'm just basically checking, is the user authenticated? If not, unauthorized result. And if they're not in this admin role, then I will return the forbid result. And that's it for the background, for the backend function. And this is very, very important, right? Because just blocking something on the front end is not enough. We could still go ahead and manually make a request to that API, and that would not be the point here. Now, for local development, you kind of want to combine these two as well, right? And for that, the Static Web Apps CLI is very, very helpful. It's a dedicated project on GitHub, and it helps you to host your static web app plus the Azure Functions together in one endpoint. And it also provides an emulator for authentication and authorization. As well comes also in terms of configuration, you can stuff like routing and many, many more. Most of that I actually didn't try, but we will focus on this combining the front and back end. And for that, basically what this does for the local development is to provide a reverse proxy. I should have ordered that a bit differently. But what you also need is to actually install the CLI from NPM, for instance. I'm not actually sure if it's available through some other way. I think only via NPM. And then once you started both your Blazor front end and Azure Functions backend, you can just call the Static Web App CLI with those parameters. That will be glued together, so to say, and then it will be available under a new port in your browser. One thing I can recommend, as of now at least, is to use Node in version 14. I think I started with 17 and I had some issues. Then at some point found out 14 works better. But yeah, just be aware of that. And to put this, I mean, diagrams are great. And I actually didn't create this diagram, but it's also from the official docs. But I think this makes it a bit more clear. So when we browse our web page, then all the static content, which is everything except these two, will be routed to our Blazor dev server. All the auth requests will be routed to the authentication and authorization emulator. And all our API requests will then be routed to the Azure Functions endpoint. And this is very interesting. I mean, this roughly also works the same way when it's actually hosted in Azure, because otherwise I haven't had the need to do this myself. But if you would deploy these things separately, then if you want your front end and back end to communicate with each other and have this authorization information, then what you would need to do is to provide some kind of API gateway. So just to make these two look like they're a single thing, maybe even, I don't know, cross-site cookies and all that stuff. So this work, yeah, just to say this works roughly the same way also when being hosted. If we browse our web page when it's glued together, then this is what we would receive. It's what we would expect. Once I would click on the login button here, you saw what I actually did, just linking to the service provider's webpage. Then we can choose one of the service providers, and then we get into the emulator. So here we can actually choose the username that I want to use for this particular test scenario, or when I'm demoing and all that stuff. And we can also provide additional roles. So in this case, we would need to add the admin role. And once this is done, you can actually, and this is still local development, we can actually go again here, reload that web page, and then actually see our code as intended. Now, one thing I also want to cover briefly is unit testing, because this is also part of the of development, not for everyone probably, but in some cases, surely. And for that, my go-to tools in most cases are XUnit and Fluent Assertions. For this particular case, we will also be using BUnit. And so we will start with testing the Azure function. So in this case, just generally good methodology, arrange, act, assert. In the first part, what we can do is, and I should note, I extracted the test base class for that, just to have some infrastructure here. But what we can do is create an auth principle, for instance, where we provide that, okay, this should be this authenticated principle should be in the role admin. You can also see I can easily create a request. In this case, it's a get request with query, but there's also another method where I can just pass an anonymous object or anonymous type, which then gets serialized to JSON. That will be the content. So a lot of freedom here. Then just the act part, simple. And afterwards, we can just take the response, check whether it's an OK object result, check whether the returned string is not empty, and that's it for the Azure function testing. For the Blazor testing with BUnit, I as well extracted a base class where I can also pass the component. And in this case, I will go with a counter, which most of you probably will know. So basically, it's a web page where you have a button to increase a counter, and below there's a paragraph which holds the current count. And this is straightforward as well. So for the to make sure that in case you need it, we can manipulate the authorization in this case. So for instance, set to a particular user. Afterwards, we can use this component. This comes from the base class. We can click increment. And by the way, those are extension methods. And if I would scroll down, then you would actually see them. But this whole thing, having this component property, which actually is a generic off counter, makes it also very easy to write extension methods to further test your components. So almost make them a bit more BDD style. And well, but we can actually go ahead and say click increment, and then afterwards also check the paragraph afterwards if it matches the new count, basically. So it was starting by 0, now it's at 1. Now I want to talk a bit about the standard deployment. So by standard deployment, I mean those things that you usually see when people talk about static web apps. And that is once you created your static web app in the Azure portal and connected it to your GitHub repository, then it will create a bunch of or a large YAML file, which is the workflow. And it will get triggered on different events, like every time we push to the main branch, or when a pull request is added or needs to synchronize, etc. And what this does is basically always updating your page. But also when someone creates a pull request, or not someone, actually, it has to be someone from having write access to the repository because it needs the GitHub token. Then what it will do is create a staging environment. And once where you can test the app separately from your production environment. And also if the pull request gets closed, it will delete that environment. Now, this is good, except the case, I mean, for many people, this will be more than enough, I guess. But particularly if you want to bring in stuff like testing, what we just looked at, and yeah, I know this is still straightforward. Could still be straightforward if you just add a .NET test call, etc. But typically, in many cases, those pipelines grow organically, and so another thing I want to talk about here with standard deployment and also management is how this looks from the management perspective. So once your app is deployed, then we will have this overview page. Here's actually, if you want to do it manually, which we will do in a second, you can grab the token from here. But other than that, we also have our staging environments here, which we can manage from here. We could delete them. And we also have role management. So the thing that we looked at before, this is where we actually put this into production. We can invite people. In this case, I just invited me. I'm a very selfish person. No, but if you invite someone, then this is what you will see. Choosing the authentication provider, providing the name, providing the different roles that you want to add the user to. And afterwards, you get the invitation link that you can then forward to this particular user. So those are a lot of things that you can do with your static web app, including the deployment. What I'm suggesting here is a different approach, which is Nuke. And I already mentioned this is the project that I'm personally maintaining, and it comes in handy in very different scenarios, as well as with static web apps in this case. And this is basically a C# make tool. Yeah, so just like if you know CMake, something like this, but with C#. Again, I'm stealing some bullet points from the other technologies that I have shown here. Powerful programming model because you can easily connect different build steps together in the way you want them to be. So, for instance, if we would have a deploy step, we can put the testing step right before that. It also has a great development experience because again, you can debug, you can actually you can let the same code run in your CI system. So not only GitHub or Azure DevOps, but you could also deploy then from GitLab, for instance. And it is scalable because something that you write with Nuke can be very easily shared with other projects, even of different kinds. It doesn't have to be static web apps. And I want to show a couple of examples here. So for the deploy target, so here I'm defining the deploy step. This is actually roughly what the GitHub action is doing. So it's pulling a Docker image, adding some arguments, and then choosing an action to actually deploy that, choosing your API and application and stuff like that. This is actually what the GitHub action would be doing. But this is a bit, let's say, more transparent about what it's happening. Besides that, you can now also actually execute that locally. Yeah. So for once from the CLI, so you could just invoke Nuke deploy. But also from the IDE here in this case, and there are also extensions for Visual Studio and VS Code. But you can also hit Alt-Enter in this case and then choose to debug, for instance, and you see I already have a breakpoint, so you can inspect what's going on. Besides that, this actually also works locally for the fact that if we don't provide an API token from the outside, then it will talk to the Azure CLI to get the token from there. So there's no need for you to manage that or get the access token for manual distribution or anything. But once your Azure CLI is authenticated, you're free, good to go. Now the even more interesting parts come in. So you will surely know I haven't shown the page, but you would need to go into the portal, create a static web app, etc., connected to your repository. But you can actually also streamline that process. And for instance, by creating a create target in this case. So this create target requires a name and then also again executes the Azure CLI just in a more fluent way, let's say. We can provide the resource group, the template file, which is actually an ARM template here on the left, and provide the name and the location. Yeah, this is basically the whole call, which you would execute on your terminal. And yeah, besides that, we also have an invite target. So this is meant to be used to invite people without going to the Azure portal, finding the correct web app, getting all the or inserting all the stuff from there. It's time consuming. And with a target like this, actually what you can do is just call Nuke invite, then -- user, provide the username, provide the roles, comma separated in this case, and provider in this case defaults to GitHub, which is actually somewhere in the config. And that will then again use the Azure CLI to create an invitation link. And in this case, I'm even using a clipboard service, which was created by Simon Kropp. Some of you may know Simon Kropp, very great OSS maintainer, to immediately copy that invitation link to the clipboard. And again, this is also something that you could streamline if you happen to have a list of users with roles, etc. You could actually create for each loops around that and email them to people. And this is all very easy because it's in C#. Just imagine what you would do with YAML if you had something like this as a requirement. Last thing here, because at the end of the day, we still want to execute this on GitHub Actions, let's say in this example, but I mentioned you're free to use any CI service that you want. But having these attributes here, and they come for all the different CI services, we can very easily make Nuke to generate the YAML file for us. So we can say this is a continuous workflow. This particular image, I want to execute it on push, but you can also choose what is dispatch workflow, for instance, to invoke it manually. We can say we want to invoke the deploy target and also pass the API token that we have to provide in the repository settings. And after that, this is the generated, auto-generated YAML file. So no need for you to write something in YAML, no need for you to commit a lot just to fix indentation errors and all like comes with caching integrated and stuff like that. And at the very end, if we commit, this is something that you will see, in this case, succeeded, of course, and we're good to go, basically, and browse the website. So just to conclude here, my personal conclusions, Azure Static Web Apps are really cool. Beside the fact that they are free for hobbyists, I can say they're, well, this is not something I can actually prove, but from the technology-wise, it's fast and scalable, fast being globally distributed with the static content, and scalable for the dynamic content that they are working in Azure Functions. One big factor here and benefit is that they are deployed and managed as a unit, front and back end. So we don't need to separately deploy our Azure function in front end, etc. I think you get it. And we have authentication providers integrated, which otherwise would be a huge pain. I would think so. And role management, as you've seen, and overall just a great development experience, because from first to last, what you've seen today was C# deployment, backend, front end, I think the end management. So I think this is great. And with that said, yeah, thanks for watching. If you're interested, you can check out the repository, also my Twitter handle if you have questions at a later time. But also, I'm not sure what the clock says right now. But if you have any questions, then let me know.
You're just in time, Matthias. What a wonderful session.
A bit over. Sorry.
Thank you so much for sharing the insights. I like the way how everything is stitched together. You have the complete solution there. Pretty nice. And so since we're running out of time, I'm going to bring in the next speaker quickly. All right. Thank you, Matthias. Bye-bye.